Alrighty, so I'm going to show you how to create a shared object. Specifically, I'm going to show you how to create a shared object using C++ classes. Now, there's a lot you can do with shared objects. And what a shared object is, in essence, is an ELF binary that you can load using other ELF binaries. For an equivalence, on Windows operating systems, because we're talking about Linux, the equivalent of a shared object is a DLL, a dynamically linked library. So we're going to be going over how to create your own shared object from scratch, and hopefully you can use it to go in any direction you want. So let's get started here. Okay. So to create a shared object, you need two files. You need your header file, and you need your CPP file. Right, we're going to just make a class called Hello World, and it's just going to print out Hello World. It's going to help you get the gist. So let's see, I have over here some notes that I'm going to use off screen. So you're going to define your header class, if I could find my reference here. So we're going to start with our .h file, right? And we're going to be using stdio. Well, I don't think we need this here just now, but we do want to use pragma once. What this does is tells the compiler to only include this file one time, in case there's any weird nesting going on. So we're just going to define our Hello World class the same way we would every other class. Okay. Now, if we had other things, we could extend this to another type of class. But for the time being, we're just going to use this. A simple one function, one constructor, one destructor. So, in order to create the constructor, it's like your normal thing, right? Since our class name is Hello World, our constructor is going to look like this. But we're just prototyping them for now. We're not actually implementing them, right? So we're prototyping our Hello World, right? It's just the constructor. And then we have our destructor. Now we're going to tell the compiler we don't want to implement our own destructor. We want the compiler to use the best practice to clean up the memory. So we're going to say the destructor equals default, which is whatever this class's compiler's destructor is set to be. So we don't have to worry about the destructor anymore. It's just already done. And then I want to have a Boolean function. I'm going to call this Boolean exec. Right? It's going to have 0 inputs, and this is a virtual function. If we had an extended class, right? If we extended a class that had its own virtual function, it would be then overwritten, right? But since we only have this, since this is the base class, we are not overriding. We are creating a virtual function. Okay, this is your bare minimum for a header file that we will inevitably turn into a shared object. Okay, so now we want to build our CPP file. So we're going to do this. We're going to be using the stdio library here to use printf. You can use iostream if you like. So the most important thing to note here we're going to implement this prototyped class. In order to do this as a shared object, you need to create what's called external functions, right? And in C or C++, whatever we're using, our external functions are all defined inside this bracket that you see here, extern, in quotations, a capital C, and then curly braces. All functions that we define, excuse me, got a little bit of a cold. All functions that we define inside these brackets, braces, will be external functions. So what we want to do is create a destructor, a external destructor and constructor function. I like to call them create and destroy, but you can call them whatever you want, and you can even implement other functions. This is how we're going to get from shared object to usable code, right? So since we have this hello world class, we want to create a hello world. So first thing, we need to actually include the header file, which I called hello.class.h. Right? So now that we have that, we can say hello world pointer, because we're returning a pointer, create, no input. We're going to return a new hello world class object. Okay. We are then also going to create our destructor, which we're going to call destroy. It's going to be a void function. Destroy hello world pointer. We're going to, as the input, hello world pointer, variable name ptr. And we're just going to do a simple delete ptr, which should free up our memory. So now that we have our external functions defined, now all your shared objects are going to have these. You may name them something different depending on your main program, but for this instance, they are called create and destroy, and we're only having 2 of them. We are now ready to implement our constructor and our virtual functions, right? To do this, it's very simple. Make sure you are outside of your external curly braces. I'm not sure if being above or below matters, but I put it below. And we want to define or implement our constructor like so. Okay. What I did was I took the name of the class, hello world, and right after hello world I put 2 colons. This is the namespace of the class. And inside that namespace we are defining the hello world constructor. All right? And in this instance, we are just going to make it say, we're going to have it echo out the namespace and function name, just so we know that it ran. Right. Now, to implement the virtual function, which if we recall I called exec, it's a bool, we are going to first define the return type of the function. We are going to then type the class name followed by 2 colons, the namespace, and then the name of the function as well as its inputs, which in my instance is just void. There are no inputs, there are no parameters. And this, I'm going to do the same thing as our constructor. I'm just going to print out the name of the function and namespace and say has run. Hello world exec has run. And since it's a boolean, we must return a bool. Okay, so this is the bare minimum. We could actually be split here, right? So over here on the left, we have our header file, right? I'll put a little comment here. And then on the right-hand side, we have our CPP implementation file. I'll call it the imp file .cpp, right? So we have our hello world here in our header file, and then we have it implemented in our C++ file. We have our virtual exec file or function in our header file, and then we have implemented our exec function in our CPP file. Okay, this is the bare minimum we need to compile the shared object, and I will go further into detail on how to use these create and destroy functions after we discuss compilation. Right? So I'm going to put my compilation stuff into a make file because I like to be fancy. To compile, so a make file, you know, the simplest make file, you're going to put all : then enter tab, and you can put your compilation stuff. You're going to use the flags fpic, F, and then capital P, capital I, capital C, fpic, and the shared flag, followed by the output name of your file, which I'm going to call hello world.so, and the input is the name of our CPP file, which in this instance is hello.class.cpp. So when I run the make command, I will generate a shared object. Now, here's where it gets interesting. You can use the readelf command with the S tag for symbols and look at your hello world shared object. Right? You could even go as far as to clear grep it for func and see all the available functions in your shared object. What's important to note here is these two right here, the create and destroy functions, which we defined in our external C code block. So any shared object that has a function within this external block, you can see the symbol name of these functions unless something is explicitly done to obfuscate it, and you can then implement these functions in your main program. For example, if I were to go to, I don't even know where my shared objects are. If I were to go to wherever I have a shared object stored on the system and run this readelf s hello world or whatever so and look at the functions, I can use that knowledge to create a main file or a main program that uses this code, right? So right now we have our own shared object that we have created using these two files right here, as well as this command to compile, this G++ command. We have created a file, a shared object file, and we now want to implement the create function. We can as well implement the destroy if we so desire, but for now we are not. Okay? So let's get started here. We're going to go and create main.cc. We're going to include stdio, referred over IO stream, and then we're going to include, just for standard's sake, stdlib And then the most important thing for loading shared objects, dlfcn dlfcn.h, which is what contains the dynamic library loading functions. So we're going to create our main func. We don't have to worry about arguments at this time, so we're just going to put void. I'm going to say exit success. Okay. So we also want to include our header file here. Wrong program. Hello class.h. I'm being lazy, I didn't want to write it. Okay. So we're including our header file in our main program, right? And mind you, our header file only contains this. It doesn't contain the actual implementation of the code. It just contains the variable names and such. So we're going to go back here. So before we continue, we're going to create a special variable type to help us better control what we're doing. It's a requirement. It'll make sense later. So we're going to say using, and we're just going to say hello type equals hello world pointer. It's a complex little type thing here, but it's going to make sense once you see it, because there's a complicated typecasting system that we have to implement. So once you have these things, right, we are ready to start implementing our dynamic library loader. So the first thing we're going to do is we're going to const char target. Right. This is our shared object input here. I'm going to get the name of this, call it hello world. Right. We need the name of the shared object we want to load, and we need a void pointer, which we'll call handle. And this is going to work like your typical file descriptor, but we're going to use a specialized function instead of your standard open or fopen. Okay, so we're going to go and say handle equals dlopen target, which is our hello world.so, and we're going to say rtld lazy. It's called lazy loading shared object. You can go to the dlopen man page to learn more about what kind of flags are available there. But for now, all you need to know is rtld lazy for the dlopen program or function. Once you do that, you want to always check to see if you had success or failure, right? And I believe this function returns null or zero, like zero, null, handle. So you could use the not logic operator to check for failure. And once you detect a failure, you can actually get the error message by doing dl error, and you can then check to see if there was an error and print that out. Simple formatting, and then of course this is our error condition, so we're going to say exit failure. If we successfully opened a shared object, then we are ready to create what I call an invoker. Okay, so we're going to use this type up here that we created, which if you have extended functions, parent and child classes, extended classes, this hello type would make more sense. But this is just a simple example for the time being. So to create an invoker, we're going to say this hello type, we're going to call it an invoker. Hello type invoker equals, this is where it gets funky. Okay, we're going to say this equals reinterpret cast. Okay, and we're interpreting as hello type. And we are going to do dlsym inside of this reinterpret cast function. And we are going to pass this dlsm or dl symbol function, our handle, which we got from dl open. And it's in this input that we can then pick which external function to load. Right? So since we created this hello world shared object, we know that there's there's an external function for create and destroy. So we want to put create into these quotes. Okay. If we were, say, reverse engineering a shared object, we would use readelf s for symbols, and we load in our shared object, look for func, grep func, right? And then we'd find the functions we want to implement, which we see here is global. We want to implement our create. This is just an alternate way to get the functions that you put into, the function names that you put into the dlsym function. A lot of functions. Okay, so once you have done this, once you have done this line, this reinterpret cast, you have what I call an invoker. You have created a specialized function. Okay? So now that you have this specialized function created, which is our create function, we are going to now create an instance of our class, which the functionality of this class is contained within a shared object, right? So we want to say hello world pointer. We'll say hello world equals, we have the typecast depending on how we're designing things, and we're going to invoke our invoker. So this invoker variable can act as a function. It's it's loading a function, so you run it like a function. Okay. Once this is done, we have created a class object using this external create function, which implements this constructor. So when we run this line of code, this invoker line, we should then see the printf result of right here. The hello world : hello world has run. We should see validation that that constructor has run. And now that we have this hello world pointer, we should now be able to execute our exec function. Right? And because it's a Boolean, we could go if this is equal to true, which it should always be because of how I designed it. Right? So this should now, we now have full access to the class object and the code within the shared object file. Right? We have run, this line of code is executing a function where the binary data was dynamically loaded into our program and executed as a single program object, right? It's taking code from one object from a different thing, independent of our main program, loading it into our main program and running it. Okay? It's a technique you can use to run SOs from other programs. Right? Now, before we elaborate a little more, you always have to remember this. After you open a file, you must close a file. And with the dynamic library stuff, you use DL close, and you pass it your handle. Okay? Now, this is important. When you close your DL, when you close your SO handle, your dynamic library handle, this hello world class object will be destroyed. Your code will no longer be usable. You can only use your dynamically loaded library stuff between a DL open and a DL close. Once you go past the DL close, you can no longer use your pointer. It will be nullified or dangling. It will no longer be a reliable pointer to a class object. Okay? So once we have this, and once you note that warning that you can no longer use this variable after you close your handle, we should now be able to compile the main program. Okay, and this is very simple, right? My make file's open over here, right? So after we compile our shared objects, we could just do G++. We want to link our DL library, so the flag tac LDL, and then we want to define our output, which was just say main, and then our input file is main.cc. Okay, that's our make file. So when we run make, it'll compile our shared object again, and then compile our main class. And now, when we run our main program, we can see that our hello world function, constructor function has run, as well as our exec function, and the return value was successfully detected. Right? Pretty cool stuff. Pretty cool stuff. There's a lot you can do with this, right? There's a lot you can do with this. Let's see here. You can, so this is a program that I've created called wfparse for parsing .obj files from Blender 3D, right? And as you can see here, I have implemented a system for counting the number of shared objects in a folder, and then treating these shared objects as commands, right? So I have a help command class, right? This is my .h file, which extends this main command, right? We are extending a different class. So as you can see here, we have our virtual exec from our extended class, and then we implement and prototype. But when we do it like this, you notice that because we're extending, we have a virtual, we can then override and implement. Okay? That's just how we pass things down and through. So that's that. Here's a quick example of a script that goes through. It's a little complicated, but it's listing folders that have .c, pp, and .h files, right? I have a commands folder, and inside that commands folder is a folder for each command. So the help file, the help command, is within a folder called help, and in that folder is a .cpp and a .h. This script will check for a .cpp, okay, and it'll get the name of that file, and it will create the output name of the shared object and put them all into a bin, right? And then compile it, right? This is how you can compile multiple shared objects within a single program. Now, this is rather complex, what I just showed you there. That's an object parser. But nonetheless, this is the simplest form of everything you need. Like, this is loading a shared object, right? Like, if I remove this hello world.so file, right, it's gone, and I run main, there's an error. Hello world.so cannot open shared object file. No such file or directory. All right, and if I were to modify the main program to use a different thing, different shared object, if it doesn't have this create function, and I don't properly design things, then it just won't work. But that's about it. It's a quick once over. Here's your make file. This is how you compile a shared object. This is how you compile a program that loads shared objects. This is the header file on the left of your hello world shared object code. This is the .cpp file on the right of your shared object code. You must implement these two external functions, and then you can implement your main functions in your class however you please. You can make them do whatever you want. And then, of course, we have our actual driving function that loads the shared object, right? You've got to have this using type function, which allows you to use this reinterpret cast. And this reinterpret cast is what takes your symbols out of your .so file and turns them into a usable function that you can use to do a whole bunch of stuff. Okay, if you want more research on this stuff, right, if you want to see how to use shared objects for some, what's it called? Reverse engineering, if you want to feel like a hacker, I guess. We have this little repository here that you can look at. Here's my GitHub, Alex Pistozo, right? And I have WS parse, which is a pretty good example of complex dynamic object loading. You can look at this repository if you choose, and then you can also look at, where is it? It's called Tor Snake. It's down here, right here. You can also see this. This is an example of using a shared object from another program inside a program that you wrote, right? This is an example of taking the Tor shared object and using it as a replacement for the sockets.h header, right? So there's examples at my GitHub if you want some examples, and other than that, that's all there is to it. I hope you learned how to turn classes into shared objects, and I hope you don't use it to do anything malicious. So, good day and goodbye.